Now let's look at the following example. We let capital F, the vector field, to be given by xi plus yj plus zk, and the parametric surface that we're going to be working with is given by a times sine of u times cosine vi plus a times sine u times sine vj plus a times cosine u, where a is a constant and the parameters u and v are in between 0 to pi and 0 to 2 pi respectively. You may recognize that this surface S is precisely the sphere centered at the origin with radius a. And what we're going to do is going to look for the flux integral of this vector field on the surface. So let's just make use of the formula that we have just reviewed to do the evaluation. Namely, we're going to convert this flux integral into a double integral. Then we could go ahead to evaluate the double integral to get our result. Therefore, we have to do some preliminary computation first. And for the sake of time, we're going to write up the result for this cross product, and you could verify the following result on your own. So it turns out Ru cross Rv is equals to a squared times sine square u times cosine square v times I plus sine square u times sine of v times j plus sine u cosine u times k. All right, with this expression of the cross products at hand, we could go ahead to start converting the flux integral into a double integral. In particular, your flux integral, it's equal to a double integral obtained by taking the dot product of the following things, which is the evaluation of the vector fields on the parametric surface with the cross product we have just computed. And since the vector field capital F is simply given by xi plus yj plus zk, so what we need to do is just replace your x by the first term, which is a times sine u times cosine v, and your y and z are respectively replaced by the second and the third component of your parametric surface. Now let's just take the dot product. And the result of the dot product would be a cubed times the sum of the following terms, which is given by sine cubed u cosine square v plus sine cubed u sine square v plus sine u times cosine square u dA. To evaluate this double integral, we will carry out some simplification. Specifically, we observe that the first two terms could be combined together and we will end up with a sine cubed u times cosine square v plus sine square v. And we just copy the very last term. Now note that the sum of these two terms, according to the famous identity of trigonometric functions, we would have a 1 down there. Hence, the double integral could be written as sine cube u plus sine of u times cosine square u dA. On the other hand, we also observe that this term is the same as sine of u times sine square of u. Hence, a similar simplification can be implemented, and we will end up with sine of u times sine square u plus cosine square u dA, while this term also adds up to 1. Therefore, we end up with a relatively simple double integral of sine of u. And if we further convert the double integral into an iterated integral, then by making use of the bound of the parameters, we will have the lower and upper limits of the first layer of the integral to be given by 0 and pi respectively. And the second layer is given by 0 to 2 pi. Now, evaluating this iterated integral, we will end up with the following. Answer. All right. Know that the evaluation of the first layer of the integral is precisely 2. And lastly, we will end up with four pi times a cubed as our answer for this example.